Hello everyone, I am Ms. Bahomet and today I am going to talk about phosphorene, a 2D material, and I am going to talk about its properties, applications and challenges. So what is phosphorene? Phosphorene, a new two-dimensional material. It seems more stable than its competitors. It is a single or few layer form of black phosphorus. Here you can see its structure. If you look at this, then you can see that it has two kind of figure, and one is called armchair and another is zigzag. If you go to armchair direction, you will see this kind of figure, and if you go to zigzag direction, you will see this kind of figure. And phosphorene comes from white or red phosphorus at high pressure and high temperature from a phase transition process. Some another properties is under atmosphere pressure it acts like a semiconductor. It becomes superconductor at high pressure. It can be switched between insulating and conducting states changing pressure. And here you can see a simple diagram where it changes is where phosphorene changes its properties, variation with pressure and temperature. At 5 gigapascal it seems like a semiconductor, and higher than the pressure between 5 and 10 gigapascal it acts like a semi material, and after 10 gigapascal it acts like a material. Okay, now let's see its application. Phosphorene has a vast application in the field of batteries, solar cell, sensor, supercapacitors, optoelectronic device. Nowadays researchers are developing some electric device also using phosphorene. But phosphorene has some challenges. At first, look at this. It takes very high cost to make phosphorene and difficult to produce, and it has some structural defect. Another challenge is there are currently no experimental method to effectively control the number of phosphorene layers and to adjust the energy level available. The stability of phosphorene immediately begins to degrade upon exposed to ambient air due to the presence of moisture or oxygen and even molecular nitrogen and hydrogen. Here I collected some information by reading a lot of research paper. Recently research topic using molecular dynamic simulation on phosphorene. The effect of mechanical strain or single layer black phosphorene at different temperatures. The temperature dependent stress relations of black phosphorene under uniaxial tension. Strength and stability of black phosphorene nanotube under axial compression. The uniaxial compression of black phosphorene nanotubes. Mechanical property assessment of black phosphorus nanotube. Effect of various defects on the mechanical properties of black phosphorene. Mechanical properties and fracture behavior of single layer phosphorines at finite temperatures. Reactive molecular dynamic simulation of the mechanical properties of various phosphorene allotropes. Compressive bulking of black phosphorene nanotubes, and etc. etc. But after studying a lot, I found some topic to be researched using molecular dynamic simulation on phosphorene. First is reactive molecular dynamic simulation of the mechanical properties of various phosphorine allotropes at variable temperature, effect of various defect on the mechanical properties of black phosphorine at variable temperature, compressive bulking of black phosphorine nanotubes with shear force or at variable temperature, and etc. could be and etc. Topics will be research in using molecular dynamic simulation.